Hey guys, welcome back to my channel. Today I'm going to continue with the pharmacology 5 marks first unit question and answers, and the sixth question is what are the factors affecting the absorption of drugs. So the factors affecting the drug absorption: number A, physicochemical factors; number B, pharmaceutical factors; and number C, patient related factors. So we'll see from first one, that is physicochemical factors. Number one, drug solubility and dissolution rate. Second one, particle size and effective surface area. Number third, polymorphism and amorphism. Number fourth, pseudopolymorphism. Number fifth, salt form of the drug. Number sixth, lipophility of the drug. Number seventh, pKa of the drug and gastrointestinal pH, which is also known as pH partition hypothesis. And number 8, drug stability. So number B, pharmaceutical factors, in that number 1, disintegration time, dissolution time, manufacturing variables, pharmaceutical ingredients, nature and type of the dosage form, and the last, product age and storage condition. So number C, that is patient related factors, in that number 1, route of administration, membrane physiology, age, gastric emptying time, intestinal transit time, gastrointestinal pH, disease state, blood flow through GIT, gastrointestinal contents, and pre-systemic metabolism. So I'll start from A, physicochemical factors, that is drug solubility and dissolution rate. So the rate determining step absorption of orally administered drugs are: number 1, rate of dissolution, and number 2, rate of drug permeation through the biomembrane. So the dissolution is rate determining step for hydrophobic and poorly aqueous soluble drugs. Example, spironolactone. So second one, that is particle size and effective surface area, in that dissolution rate of solid particles is proportional to the surface area, and the smaller the particle size, the greater the surface area, then higher will be the dissolution rate. Number third, polymorphism and amorphism. So when the substance exists in more than one crystalline form, the different forms are designated as polymorph, and the phenomenon is known as polymorphism. So what is amorphism? In some drugs that can exist, the amorphous forms such as represents the highest energy of the drugs. So number 4, pseudopolymorphism. So when the solvent molecules are entrapped in the crystalline structure of the polymorph is known as pseudopolymorphism. And salt form of the drug, while considering the salt form of the drug, the pH of the diffusion layer is important, not the pH of the bulk of the solution. So number 6, drug stability. A drug for oral use may destabilize either its shelf life or in the gastrointestinal tract. So B, that is pharmaceutical factors, disintegration time. So the disintegration time for the tablet is directly proportional to the amount of the binder and the compression force. So the fast dispersible tablets have shorter disintegration time. Dissolution time. So it is a process in which a solid substance solubilizes in a given solvent, that is mass transfer from the solid surface to the liquid phases. So number third, manufacturing variable, in that method of granulation and compression force are available. So number 4, pharmaceutical ingredients or active pharmaceutical ingredients. So commonly used excipients are vehicle, diluents, binders and granulating agents, disintegrants and lubricants. So number 5, product age and storage condition. So it can adversely affect the bioavailability by change in the specially of physicochemical properties of the drug form or the dosage form. So number C, patient related factors, in that number 1, route of administration. It has parenteral, oral and transmucosal routes. So we'll see parenteral route. They avoid the possibilities of the hepatic first pass metabolism. And number second, membrane physiology, in that nature of cell membrane. Number third, age. So in infants the gastric pH is high and intestinal blood flow to the gastrointestinal tract is low, which results in the altered absorption pattern to compare with adults. So number 4, gastric emptying time. It is required when the drug is best absorbed from the distal part of the small intestine. And number 5, intestinal transit time. So it is a major site for absorption of most of the drugs. Number 6, disease state, where the gastric disease, they may not have an adequate production of acids in the stomach. So stomach HCl is essential for solubilizing the insoluble free bases. And number 7, pre-systemic metabolism. So loss of the drug through the biotransformation, by which eliminating the organs during the passage to systemic circulation is called pre-systemic metabolism or first pass metabolism. So question number 7, what are the factors that affecting the metabolism of the drug? So the factors that affecting the metabolism of the drug are, first one, chemical factors, in that A, enzyme induction, enzyme inhibition and environmental chemicals. And second one, biological factors, in that A, age, diet, sex difference, species difference, strain difference, altered physiological factors, and number third, physicochemical properties of the drug. So we will see from the first one, that is chemical factors, and in that enzyme induction. So the phenomena of increased the drug metabolizing ability of the enzymes by the several dosage form and the chemicals is called as enzyme induction. So in enzyme inhibition, where the phenomena decrease the drug metabolizing ability of the enzyme. So in enzyme inhibition, it decreases the metabolism of the drug for the ability of the enzyme. So it is called as enzyme inhibition. And number C, environmental factors or chemicals. So several environmental agents which influence the drug metabolizing ability of the enzymes. Example, halogenated pesticides such as DDT and the polycyclic aromatic hydrocarbons contained in cigarette smoke have enzyme induction effect. So number second, that is biological factors, in that A, age, in neonates up to 2 months and the infants 2 months to 1 year, the microsomal enzyme system is not fully developed. So many drugs are metabolized slowly. B, diet. So low protein diet decreases the high protein, and high protein diet increases the drug metabolizing ability of the enzyme. So it is the synthesis where promoted by the protein diet and also raises the level of amino acid for the conjugation with the drugs. Number C, that is sex difference. So the variation between males and females are observed by the puberty. So sex difference related in the rate of metabolism may be due to the sex hormones. In D, species difference, it can be observed in both phase 1 biotransformation and phase 2 biotransformation reaction. So in phase 1 biotransformation reaction, both qualitative and quantitative variations are in the enzymes and their activity has been observed. So E, strain difference, just a difference in the drug metabolizing ability between the different species is attributed to the genetics. The difference are observed between the strains and some species also. It may also be studied under the two headings or the two types, that are pharmacogenetics and ethnic variations. So F, that is altered physiological factor. So in altered physiological factors, it comes under the pregnancy, disease state and hormonal imbalance. Number third, that is physicochemical properties of the drug. The molecular size, shape, pKa, acidity, basicity, lipophility and steric and electronic characteristics of the drug are influenced in the interaction with the active sites of the enzymes and the metabolism to which it is subjected. However, such as interrelationship is not clearly understood. So question number 8, write a note on metabolism of drug by phase 1 reaction. So you have to refer medicinal chemistry 1 4th sem first question for phase 1 biotransformation. So question number 9, write a note on metabolism of drug by phase 2 reaction. So here also you have to refer medicinal chemistry 1 4th sem question and answers, with that is question number 2nd. So coming to the next question, that is 10th, write in detail about different routes of the drug elimination. So drug elimination, it is defined as a process by which the drug metabolites are irreversible transfer from the internal to the external environment through renal or non-renal route. So the principal organs which are involved in the drug metabolism, drug elimination, that is kidney, that is renal excretion, bile, biliary excretion, lungs, pulmonary excretion, saliva, salivary excretion, milk, mammary excretion, and sweat, skin excretion. So we will start from the first one, that is kidney, renal excretion. So the drugs that are eliminated from the body primarily by the kidneys. So the principle for renal mechanism are glomerular filtration, active tubular secretion, active tubular reabsorption. So first one, that is glomerular filtration. So the ultrastructure of the glomerular capillary wall is such that it permits a high degree of fluid filtration while the restricting the passage of the compounds that are having relatively large molecular weights. So compounds with 20 degree angstrom to 42 degree angstrom undergo glomerular filtration. So number 2, active tubular secretion. The active tubular secretion which is carried out at the level of the proximal tubule in an active process. And number 3, active tubular reabsorption. In the distal tubule, there is a passive excretion and reabsorption of the drug which are present in the glomerular filtrate that can be reabsorbed in the tubules. So number 2, that is biliary excretion from bile. So the transporter are also present in the canicular membrane of the hepatocyte, and these actively secretes the drug and metabolites into the bile. So number 3, pulmonary excretion. So it obtained from the lungs, the gaseous and the other volatile substance such as general anesthetics that enters the body primarily through the respiratory tract, which can be expected to be excreted by this route. So the rate of loss of gases is not constant. It depends upon the rate of the respiration and the pulmonary blood flow. So saliva excretion through saliva. So the pH of saliva varies from the 5.8 to 8.4, that unionized the lipid soluble drugs are excreted passively. So the bitter taste in the mouth of the patient is the indication of the drug excreted. In some basic drugs, it inhibits the saliva secretion and are responsible for the mouth dryness. So compounds that excreted in the saliva are caffeine, phentine and thiophyllene. And mammary excretion, that is from milk. Milk consists of lactic secretion which is rich in the fats and the proteins. So excretion of drugs in milk is important as it gains entry in the breastfeeding for infants. So the pH of milk varies from 6.4 to 7.6 free unionized, and the lipid soluble drugs diffuses passively. So skin excretion, that is sweat. So drugs excreted through the skin via sweat, which follows the pH partition hypothesis. So the excretion of drugs through which skin, which may leads to the urethrica and the dermatitis, where the compounds like benzoic acid, salicylic acid and alcohol and the heavy metals like lead, mercury and arsenic acid are excreted in sweat. So here we have completed the 5 marks of pharmacology 4th semester from unit 1. Tomorrow I am going to give the 2 marks from the first unit. So please do like, share and subscribe to my channel. Thank you very much.